Yeah, hi, good evening all. Dr. James Lani with Statistics Solutions. Thank you very much for joining us around talking about quantitative analysis. Where should we start here? So everyone has gotten through the concept paper, right? We've gotten through the methodology. And the key to quantitative analyses is that we're really just following the data analysis plan that's been approved, okay? So if you're not sure about the data analysis plan, that's got to be crystal clear. So, and what I mean by that is, in that data analysis plan, and then I'll jump right into the implementing of those analyses. So you need to have in that methodology, in that data analysis plan, you need to tell everybody, okay, gosh, we're going to clean the data, we're going to describe the data, we're going to conduct these analyses with these assumptions, and then summarize them. So what I'm going to do here is, the kind of the overview is, I'm going to talk about basically what I just said, walking through those steps. I'm going to present some of the analyses that are, pretty common, and some that are not. And then I'm going to review Statistics Solutions Pro, kind of our shortcut to being able to give you accurate results in a very fast fashion. And so let's get started. So the quantitative results, first of all, as we just said, you want to clean data, then describe the variables. What I mean by describe is if you have nominal level variables or ordinal level variables, you want to show the frequency and percentages, and I'll show you, exemplify that in a bit. And then for your continuous level variables, interval and scale, then you'll want to show the mean, standard deviation, and some people like to show the range of that. So you're going to clean the data, then we're going to conduct descriptives, we're going to conduct the analyses, we're going to examine the assumptions, because you want to make sure those results are trustworthy, or robust, as some people like to say. And then we're going to present and summarize those findings, okay? Oh, by the way, if you have any questions throughout, feel free to type it into your chat window. I'll be happy to answer them as they come along. We actually had one already from Roberta. We'll get to yours, Roberta. We will get to yours as we look over some of the analyses. But I certainly invite your questions, okay, throughout, and just type them in there. So, data cleaning and prep. You can see the cute picture of someone cleaning the data. So, some basics around data cleaning. Certainly, you want to, certainly assess for outliers, okay? Basically, an outlier is someone that is plus or minus 3.29 standard deviations away from that mean, okay? Although I did speak with an EDD gal recently, and she said, no, we like outliers, we keep them in there. So just check to see if that's what you want to do or not. Oftentimes there's missing data. So there's lots of ways to remedy that. In the old days, they used to just kind of take a variable and say, hey, you know what? Case number one is missing the value. Well, what's the mean of everybody else, and stick the mean in there. Now there's fancier and really kind of cool ways that multiple imputation really takes into account the whole data set, okay, and then imputes that missing data point based on not only that variable, but the rest of the variables and the rest of the data set. So it's kind of cool. Creating composite scores. So basically, people have surveys that measure some construct like self-efficacy, and you need to create a composite score or an average score or a mean score. Just heads up, some of those items are sometimes reverse coded. When you conduct that Cronbach alpha, you'll find out, hey, the alpha is really bad. Well, when you look at that Cronbach alpha or the reliability, you can look to see, well, if I deleted an item, how would that affect the alpha? All right. So create composite scores. Just be careful about what variables or reverse variables you're using to create that. And then assess for normality. A lot of the tests want that normality assumption, which is in our cases, just think about like a bell curve. It should look like a bell curve and not deviate too much from that curve. Okay. So descriptive stats, as we said, we're really just talking about frequency and percentages. Sometimes they don't always add up to 100 because of a rounding error, okay, or rounding. So just heads up on that when you're doing that. Okay. Now, we're going to move into some of the different tests, okay? So the two tests that are very similar is goodness of fit and test of independence, okay? So basically, it answers the question, it's a lump meter, essentially. So if you look at the tables and figures, it's really a table. So, when we're looking at the political affiliation, for example, right? And let's just say you had 250 people. Gosh, so what this chi-square test really assesses is, hey, is there like, 249 Republicans and everybody else has a 0 in it? So a lump meter was that one of those cells would be lumpy or larger or disproportionately smaller than the others, okay? So by chance, they should all be equally equal. The sample should have an equal sample size in each one of those. Ditto for the figure, the table below that. Even if you have a two-variable table like gender and political affiliation, again, you're still looking for that lumpiness. And essentially, both of these guys are really looking at, what is the actual observed frequency in that cell compared to what would be expected by chance, all right? And then there's assumptions associated with it, which are essentially, does each cell have a count of 1, and do we have an expected value of 5 in 80% of them? And then you would just conduct the analyses. So, and I'm moving through this quickly, so if there's questions, and we do have questions, and I'll just kind of take them as we go. So one question is, what's your opinion of using descriptive stats on qualitative data, nominal or ordinal? Sure. I mean, and in fact, part of grounded theory is looking at the frequency in which these themes are present. So yeah, I think that's really appropriate, right? Elizabeth is asking, let me see this. How much? Okay, so Elizabeth is just kind of asking about, hey, if we enlist statistics solutions help, as I hope you will, we do have really good people here. How much do they help with the data analysis steps? We help as much or as little as you'd like. I mean, at the end of the day, I like to think of the end in mind, right? You have to have a clean data analysis plan and one that's approved. Right? So the last thing, kind of like the carpenter's rule, you measure twice and cut once. Well, with data analysis plan, you want to write it and you want it approved prior to you conducting it. If you don't get it right, that is the writing of it and the, no pun intended, and the approval of that, then you're going to wind up conducting those results twice, which nobody wants to do. So we do help. In fact, we have templates online, but we could also actually just kind of walk you through that, and we could certainly draft that up. So just call our number, which I think will everyone has, or we'll present at the end of it, and I'll go over it as well. So, and I'll just take one. Well, let me go over this a little bit, and then I'll get to Roberta's question. So, what does the Pearson correlation do? So when the chi-square was looking at nominal level variables to see, hey gosh, is one of those categories, okay, or levels lumpy compared to the other ones, okay? And that's particularly in that latter one with goodness of fit. or test of independence, pardon me. You know, we're seeing, is there a relationship between political affiliation and gender in nominal level variables or frequencies, essentially. In the correlation, we're looking at the relationship between two variables too, except we have different assumptions and we're using scale level variables, okay? So Pearson correlation looks at that relationship, and with answering or understanding, hey gosh, there is no significant relationship, okay? Or, yes, there is a relationship, okay? And that relationship is either positive or negative, okay? So the more positive relationship, the more I exercise, the better my mood. Positive relationship, you know, perhaps negative relationship, the more I make, the more the less I save, or, well, that's not really a great example. So just negative relationship is that they're in opposite directions. And maybe somebody could type in a negative relationship example for me. Okay, so, and just quickly, the assumptions are linearity, homoscedasticity, and normality. Essentially, the linear or linearity assumption, you can see the linear and nonlinear, what they may look like, okay? Did it with homoscedasticity, the kind of spread all the way through of those values, and normality is the bell curve rather than a non-normal situation. Okay, so Roberta had a question. She said, my research is using two instruments, one developmental, okay, and the other one is leadership. Perhaps it should be obvious, but I'm struggling to determine how to bring these two questionnaires instruments together. Looking at correlations between the DV, developmental, and IV. So I guess one type of approach is kind of a correlational study, okay? And the other one is a causative comparative study, okay? So in the correlational study, you know, we're just trying to relate two variables, and the simple example is, you know, shark bites and ice cream cones. You know, are these two things related? Oftentimes they are, right? The hotter it is outside, okay, shark bites go up because people are swimming and people are eating ice cream. But one doesn't cause the other, right? Sharks biting people doesn't signal, hey, go get ice cream, and people going eating ice cream doesn't signal to the sharks, go bite people. So in a correlational study, we're really just looking to see the relationship between them. In the causal comparative, we are trying to show some cause-effect relationship there. So like temperature causes or influences, okay, ice cream cone sales, for example. So the way that you tie these things together, I mean, you're kind of saying it already that, you know, in a correlational study, you really don't have an IV and a DV. You know, you just kind of have two variables there because one is really not driving the other. So if you wanted a correlational study, you'd say, hey, gosh, are these two things related, right, and just run a correlation. If you wanted to do a causal comparative kind of approach and say, gosh, I really think that the IV, leadership skill, really influences developmental experience, okay? And then you would just kind of run a regression, and I'll get to that, you know, a little bit down the road. So your statistical approach matters, okay? And the kind of relationship, well, the type of relationship, either correlational or cause and effect, you know, should be clear, and then the analysis should reflect that. So, okay, so let me just peek at the, I'm working on a quantitative correlational study. Okay, we just talked about that, right? Correlating burnout to patient acuity and complexity by unit when standardizing nurse-patient ratios. Which would be most appropriate, Pearson graphs? Okay, so the fact that you're talking about a correlational study, as I just said, we're not trying to show cause and effect. So you're saying, hey, gosh, you know, burnout and acuity are related, but burnout's not causing acuity, and acuity is not causing burnout. Well, Andy, I would say perhaps that you really are trying to show something. That, you know, a lot of patients with acute issues might really stress out the people. So just think about that. If it's what kind of study you're really looking to do. Okay, and thanks, Rick, for the negative correlation example. The more I work out, the less I weigh. Awesome example. Good. All right. And then let's just go down to Donna. Okay, same example. Donna and Rick, good minds think alike. Okay, so now let's just go to, so that's the Pearson correlation. Again, these are just very common analyses. Okay. Independent sample t-test. Okay. Basically, this is answering the question, like in the table, you know, hey, there were differences in gender on IQ scores, for example. So essentially, you have a continuous level dependent variable, in this case IQ, and then you have a nominal level or categorical level independent variable, like gender. Okay. There's assumptions of homogeneity of variance and normality. We've talked about normality. It's like a bell curve. Homogeneity of variance is that if you look at the chart for the males and females with participants 1, 2, and 3 with scores 1, 2, and 3, okay, there's a mean of 2, and then there's also a variance, okay, or standard deviation there, okay? So those variances in the males and the variances in the females, those should be similar. So they would be homogeneous if they were similar, and that assumption, you know, needs to be met. Now, by the way, as an FYI, the t-test is a very trustworthy, robust test. I'll say independent of violations of those assumptions. So particularly if normality, if you have over 50 participants, Stevens out of Cincinnati, he would say that, you know, you can really violate that assumption. Homogeneity of variance, it might inflate or you know, make more conservative or liberal your F value or your T value in this case. By the way, I want to just kind of give everybody a little quiz here, okay? So when we're thinking about differences on IQ scores by gender, right? So look at that first example with participant 1's got a 1, 2's got a 2, 3's got a 3. Participant, now we're into the female group, participant 4's got a 2, 3 and 4 are the scores. Now the mean difference between males and females is 1. So my question to you is, here's the test of the night, no grades. Would you be willing to say that these two groups differ from each other if they differ by a number of 1 between them? Okay. So everybody, you can just put in your put in your answers. We'll be awaiting. Okay. All right. And Douglas said no. There's a couple of yeses, couple of no's. We are trying to get full-on engagement here. And okay, we got no's, we got yeses. No, no, yes, yes. Okay. So for a lot of yeses, okay. Okay. Well, the correct answer would be no. They don't differ between the groups in this example because they differ by 1 even within the same group. So we're not willing to say that they differ between groups. If you can differ within your own group by 1, we're only differing between groups by 1. And in fact, that's what the t-test is really showing, right? It's saying, gosh, we're looking at differences between the groups, and we're using as a divider the differences within a group. And when the differences between the groups are really big and the differences within the group are really small, you get a really big ratio, a really big number. And that bigger number is more likely to be statistically significant. Okay, well, let's go to the next example, carrying on here. Now, we have males with participant 1, 2, and 3 with their scores, females 4 through 6 with scores 2.9 to 3.1. Now they still differ. They still differ by a number of 1, right? But now look how they differ within a group. It's just 0.1. So here's the second part of that test. Now are you willing to say that these groups differ by gender? All right. Yes or no would be the answer. One of those. Okay. All right. All right. So a lot more yeses here. A lot more yeses. There's still a couple of no's, okay? A lot more yeses, couple no's. Okay, so the answer is yes. We are willing to say that they differ between groups because they differ by 1 between the groups, but they only differ by 0.1 within a group. Okay? So, yes, when the differences between the group is much greater than the differences within a group, we say, they probably do differ. They probably are 2 different samples or 2 different populations. Okay? All right. And I'm happy to go over that. We do have a web page around t-tests for sure, and we're happy to assist you with kind of really helping you pick the right test, but also implement the right test, table the right test, and then really make sure that you understand it, okay? Because it's really important when you go to write that discussion chapter to generate the right results, interpret it correctly, and then be able to defend it, okay? So, all right. Okay. Okay, so someone's bringing up ANOVA, so we're going to go right to ANOVA, okay? You guys are right with me. So ANOVAs really are look at differences on some score, like IQ, for example, okay, by, it could be 2 variables or 3 variables or more. So while a t-test only has 2 categories, like male and female in the past, the t-test, here you can have 3 or more categories. And you can just see different scores for participants 1 through 9, okay? And you still have the same assumptions. Apologies for the typo on analysis. And but basically we're doing the same thing, just 2 or more groups, okay? All right. Okay. All right, so the dependent sample the dependent sample t-test, the independent sample, that is males are different than females in terms of their groups. Here with the dependent sample t-test, you have the same participants, for example, over time. And in this example, we're looking at the same the same participants from pre to post test, okay? And you can see I had participant 1, 2, and 3 at the science pre-test, and I have participant 1, 2, 3 at science post-test, okay? And again, the same kind of analysis is going on, which is we're just trying to see, are there differences over time, okay? And the dependent sample t-test is really just looking at 2 levels, pre and post, or something of this sort. Okay? The repeated measures ANOVA, which is analogous to the regular ANOVA, which also has, it can handle 2 time periods or 3 or more, okay? So the independent sample t-test is different groups. The dependent sample t-test is the same group over time. The ANOVA looks at 2 or more groups. The repeated measures ANOVA, 2 or more time periods, for example. Okay. I was going to say something else about the ANOVA, though. I'm sure it will come to me. Okay. I'm going to go back to the ANOVA for a second. One thing I didn't mention was that the ANOVA really assesses, so you have, and I should have put this in here, you have Republicans, Democrats, Independents, okay, and everybody's got a score, right? But there's also a grand mean. If we looked at everybody as a whole group, they'd have a grand mean and a standard deviation. Okay? So the ANOVA really says, hey, do one of those groups differ from the grand mean? That's literally the calculation that's being assessed. So what I wanted to mention was that with ANOVAs, significant ANOVAs and significant repeated measures ANOVAs, that there's another step, which is the post hoc test. Because really our question is, it's not if one of those groups differ from the grand mean. What we really want to know is, do Republicans differ from Democrats? Do Republicans differ from independents? And the Democrats differ from independents? So we want to look at those post hoc tests or each combination, okay, to see if they differ from one another. Did it with the repeated measures ANOVA. We also want to do a post hoc test to see, hey, does pre differ from post? Does pre differ from follow-up? Does post differ from follow-up? Okay. Another very common analysis is the linear regression. And if you have, a linear regression is just really with one predictive variable, one outcome variable. Multiple linear regression, you have multiple independent variables, again with one dependent variable, okay? There are assumptions to be had with linear regression, okay, normality, multicollinearity, and homoscedasticity. The multicollinearity just comes into play when you have more than one predictor. And basically what it assesses is how highly correlated are the independent variables. And if they're really highly correlated and overlapping, then you need to remedy that, okay? The multicollinearity assesses that level of relationship or correlation among those IVs or independent variables. Okay. Now, there's also, well, and it answers the question, basically, okay, out of all the reasons why the dependent variable can vary, or creativity, you know, what percent of the reasons are accounted for by IQ? And the R-squared value really gets you that answer, okay? So one of the, and maybe I should have said this as well, and I'll go back. For the linear regression, you really want to present several things, right? You want to present the F value, okay, which is essentially, hey, overall, how well does this IV or these IVs, independent variables, plural, how good a job they do in predicting or counting for variability in the dependent variable. The other thing that's reported with in the linear regression or multiple linear regression is each one of the predictors, and they have what's called a beta weight, okay, and a beta weight essentially gives you a clear indication of, hey, if the beta weight increases by 1, how much does the dependent variable score predicted to increase or decrease, okay? So, and we can assess each one of those, the F by itself, and then each one of the beta weights by themselves, or each one of the predictive variables, okay? Okay, so now there's 4 types of regressions. And as I state here, you know, it's all about the level of measurement of the dependent variable. Absolutely true. In multiple linear regression, okay, the outcome variable is a continuous level variable, okay? That is a continuous level score. I'm curious, does anybody need me to mention what a continuous level variable is? The logistic regression has an outcome variable that has a dichotomous outcome, like does IQ predict gender, something like that, or some dichotomous outcome. You can have an ordinal level variable, like perhaps age groups, okay, or you can have a multi-nominal level outcome variable, which is, you know, for example, political affiliation. So can IQ predict political affiliation? Maybe not the best example in the world, but basically it's a categorical variable with several outcome variables. So I want to just answer a few of these questions. Explain what a continuous level variable is. So we really have, I'm going to say, well, let me just call it 3 levels of variables, okay? Levels of measurement of the variables. You have a nominal level variable, okay? Nominal is Latin for name. So it's just in name only, like male, female, or green, independent, Republican, okay? So just think of nominal as name. That's the mnemonic. And so it's just categories, okay? Now, I may assign a 1 to Republican, 2 to Democrat, 3 to Green, but I could have easily said, you know, 3 was Democrat and 1 was Green. So again, it's just categories. So the first level of measurement is nominal or categorical. The second level is ordinal. And in ordinal, you really have different ranges. So, for example, you can have age group from 0 to 12, and then you could have teenagers from 13 to 19, and then you could have young adults or young adult through old age, you know, 20 on. Okay, so you have categories like in nominal, but they're ordered categories. So that's the mnemonic, ordinal and ordered, okay? So they're in order. But they don't have equal, I'll say equals, it doesn't necessarily have to have equal numbers inside of it. So in my example, I said I have 3 age groups that are ordered, 0 to 12, 13 to 19, 20, let's just say up to 100, okay? And in 0 to 12, you have, okay, 13, let's just say 13 ages there. 13 to 19, you have 7 ages there. And 20 to 100, let's just say you have, you know, 81 ages there, okay? So the same amount doesn't have to be in each one, but they are ordered, okay? The last level of measurement is really, I'll call it scale, okay? And scale takes into account both interval level variables or interval level measurement as well as ratio level measurement. Essentially, just think about it in terms of, I'll just say, age with the actual number, okay, or the number of days you've been alive. It, you know, well, let's just go by age for the moment, you know. 1, 2, 3, all the way up to 100, okay? And that the intervals between each age is exactly the same, okay? So the number of days between ages 1 and 2 is the same exact number of days between 2 and 3, and so forth, okay? So that's interval, and oftentimes Likert type, it's really pronounced Likert, but for the rest of everyone it says Likert. Likert type variables, the you know, when you have strongly disagree to strongly agree, most people consider that an interval level variable, okay? Again, with equal intervals between them. Ratio, it's really an interval level variable, but it has a 0 point, okay? Like a score on a test, okay? You can have a 0 all the way up to 100 or some thing like that, okay? So, just to review, we have 3 levels of measurement: nominal, ordinal, scale, okay? So good question. It's important to know. By the way, in our software, I know we're going to get to it, but I'll highlight that it really lays that out as well, okay? It's kind of a tutorial level thing. Right. All right, Andy's asking about leap years. Okay. Stepwise regression, multiple regression. So stepwise is the way, so there's different approaches in regression. Most of it is I'll just say an enter method, where all of them are kind of going in simultaneously. but you can have they have a backwards, forward, stepwise approach, which is essentially saying how the variables are entered into the analysis and how they're removed from the analysis. So in this example, and the default is an enter method where they're entered simultaneously, but there are other methods in which, again, that variables are entered or removed from the equation. Okay. So those were kind of the basic analyses, you know, chi-squares, t-tests, ANOVAs, and so forth. But I want to talk about mediation and moderation. And the reason I want to talk about these is that, you know, what I often see, you know, are really, okay, let's just say, some of the research questions aren't the best, and we need to beef them up a little bit. This is one way to beef up those research questions without adding any more data, okay? But it's a little bit faster of analysis that really will forward your efforts in getting it past the committee and URR and IRB and so forth. So mediating variables and mediation analysis to assess potential mediating variables, you know, really looks at, you know, a mediating variable is a variable that carries the relationship between two variables or explains the relationship between two variables, okay? So you have the assumptions of regression, and so an example is, hey, you know what? We have found that IQ really influences creativity, right? We've looked at people's IQs around the globe. We've looked at people's creativity, and what do we find? One predicts the other. Okay, great. But then somebody says, well, I got a demographic variable of education. I wonder, right, we get to hypothesize, I wonder if education is a potential mediating variable. And we can assess that. And we assess that via 3 regression equations, right? And in that assessment, and we'll show you in real time on the software too, hey, does the IV predict the mediator? That's one condition that must be satisfied. That needs to be significant. The IV must predict the dependent variable, the DV. That must be statistically significant. That's the second condition. Third condition is, hey, when I enter into the regression, the mediator and the IV, predicting the DV, the IV should no longer be statistically significant, okay? So there's conditions around it, but it's kind of a cool, easy way to beef up your research questions, and which we're happy to help with. And that make things a little bit more interesting, okay? And it will be a little bit interesting. This depends in part on surprisingness, and it'll be a little bit surprising, and then have your professors think, okay, that's kind of interesting, okay? All right. So mediation is one way to beef things up. All right. The other way to beef things up is really with moderation analysis. So moderators, while mediators explain the relationship between two variables, moderators really strengthen or weaken the relationship, okay? So, for example, we have, IQ influences creativity, and we wonder, hey, gosh, as people get older, does that relationship get stronger or perhaps weaker? So that's what moderators do, or we can assess for. Again, another way to kind of strengthen that research question without adding, much other data, okay? And the analysis isn't that much tougher either. We'll kind of, we'll get to that. So the way that moderators are assessed are essentially in a regression, you enter in, I'll say step 1, or some people call it block 1 in SPSS language. And, does IQ, you enter in IQ and age, predicting creativity. Then you create an interaction term, which is a fancy word to say that you multiply those two things. And then you, the product of those, and then you enter in that interaction, okay, and see if that's significant. And if that's significant, then moderation is supported. If it's not significant, moderation is not supported. By the way, I put a note down below. Remember we talked about multicollinearity earlier? that two variables are going to be highly correlated in a regression? Well, think about it. If the interaction term is made up of one of those variables, well, both of the variables, but there's a good chance that one of those variables and the interaction term, okay, is highly correlated. So to avoid that multicollinearity, what you want to do is center, okay, each the IV and the moderator. And what that means is really just subtracting the mean from each. So you have the list of the independent variables, and for each one of those observations, you're just subtracting the mean from that, okay? That's centering the IV. You do the same darn thing for the moderator. Then you create the interaction term. Okay. All righty. So I just wanted to point out Jeremy Dawson out of the UK. So, sometimes when you have continuous level variables, right? What do we have here? Age and IQ, those are continuous level, and the moderation is supported, that is, the interaction is significant. It's kind of hard to understand sometimes, well, in what way is it significant, okay? So this guy, Jeremy Dawson, really came up with a cool Excel sheet that allows you to enter in the moderator and the beta coefficients from the regression and really plot it out. And, in this particular case, you can see, whatever the outcome variable is, let's call it IQ. When the IV is low, well, pardon me, let's just call the DV creativity, as we did before. Let's call the IV IQ. So in this particular example, and then age is our potential moderator, right? So in this particular case, well, we have gender in there. Sorry. Well, the IV, so really in this case, gender is the moderator. Sorry, I should have kept the same example. In this case, when the IV IQ, okay, when IQ is low for women, okay, creativity is high. As the when the IV is high, that is high IQ for women, they have lower creativity. So anyway, it's just a way of plotting things out, and it makes it easier to visualize. I apologize that the example's not perfect. Okay, I want to go to our quantitative analysis. So this is a really quick, easy way of conducting a results chapter, okay? So let's just do it. Okay, so we're just going to hit play here, and I'll just kind of walk through it, okay? Basically, in our application, you're just going to sign in, okay? And then we have a little welcome. It says, hey, how you doing? We're going to do 3 things, okay? Then you're going to upload data, okay? And then hit upload. So basically what it's doing is it's taking the data and it's reading all the variable names and it's assigning a level of measurement to it, okay? And it just takes a few seconds for it to do that, and then you have your data. So I just wanted to highlight over here is really kind of remind you of what nominal, ordinal, and scale level variables are, okay? And I apologize for the, it's lost some resolution looking at it, so it's much cleaner on the website. So essentially, it reviews those levels of measurement that we talked about earlier. And what you have here is all the variables, and then the levels of measurement. Now, you can change the levels of measurement, and we'll get to that in a second. But I just wanted to highlight. So, for example, if you wanted to change the level of measurement of gender and actually go from scale to nominal, so you can change these levels of measurement. Okay. By the way, the reason why we want the accurate level of measurement is that the application is going to only let you select the analysis that have the right level of measurement in there. So you want to make sure that the level of measurement is perfect for what you're trying to do here. Okay. All right. Then we have other data management tasks like reverse coding a variable, okay, for example. And it's in a much more friendlier environment than SPSS, okay. You can create composite scores. So after you reverse code any variables that you might have, you can put in the variables that you want to compute a composite score on, and then just name that new variable name, and go to the next analysis. Okay, so I should have just stopped. So you can just see under the tasks over here that it's also tracking all the things that you're doing, okay, so that you can remind yourself. All right. Okay. So I also want to highlight a couple things here that these are all of the tests in blue that are currently available. Okay. Chi-square, correlation we just talked about, ANOVAs and COVAs, which is the adding a covariate or controlling for a variable. Different types of regressions. There's, underneath my little window here, there's non-parametric variables. And then we're adding we've added mediation and moderation. And then we're adding other fancier analyses too, like structural equation modeling and things of that sort. So I just want to highlight that we have a full array of these analyses, all available, $2.99. It's for a year license, and that includes when all those other variables, all those other analyses come online, you're going to be able to lock in your fee, okay? So if you think you're going to be doing a different kind of analysis later on, it's a good time before prices might well change. Okay. The other thing I want to mention is that we have a scroll over feature. So we're trying to teach as we go here. So again, it's not crystal clear, but when you scroll over each one of these enabled analyses, it's going to tell you what that analysis is, just to kind of remind you so you can recognize the correct analysis. Okay? Chi-square is only going to let you put in nominal level variables. Okay? All right. Pearson correlation, all right, allows you to put to correlate up to 10 variables. Okay? And then we're just going to put in a few variables to correlate. And we're going to put in the total, and we'll put in one more. And then accept the changes or accept the analyses. We'll run an independent sample t-test, which is allowing you to have a continuous level dependent variable and a categorical, pardon me, let me say that again. So the independent t-test, continuous level dependent variable, and a nominal level independent variable. Okay. It also conducts regressions with up to 10 predictive variables. Okay. And we're just going to stick in some of the different predictive variables. Okay. All right. All right. And then with mediation, right, we talked about having 3 regressions. This is going to conduct all 3 regressions simultaneously, and I'll show you in this output. So, you know, this application makes it really simple to put in the variables. Okay. Then, when you're all ready to go, there's a few buttons here. If you said, uh-oh, I really made some mistakes here, you can always start over. You can, if you are comfortable with the data management that you did, you can always download your data with that data managed, okay? And as we're going to click on right here, we can download your analyses. And this is the coolest part of the whole thing, okay? Particularly for grad students, and particularly for people in intro stats, for intro stats, intermediary stats, and perhaps research methods classes. And in the time that I was talking, it already, this quickly, did all of those analyses and wrote them up and dynamically interpreted them. You ready? You're going to click OK. And you're going to get everything in a Word document. So on the top it says, hey gosh, this is a template. It describes your data management. It describes the analyses that you put into it. Okay? Then under the data management, it shows you, hey, I reverse coded this. I created the composite score, and then automatically conducts a Cronbach alpha for you to say, hey, how reliable was that composite score that you created? After the Cronbach alpha, we get right into the results. Part of those results are doing descriptive analyses on those nominal level or interval, nominal or ordinal level variables. So frequency and percentages. Okay, and in a real cool fashion, we create a table, APA table. You're not spending 20 minutes exporting it, formatting it, putting it into a Word document. You're all grad students. We don't have time for this. This does it for you. All right. So does tables of frequency percentages. Then we get into the continuous level variables. It describes the mean, standard deviation. This is a terrific template for you that you can use and start working off of. Okay? And again, you may want to tune up the names of the variables and so forth, but you have a working lattice that you can now start hanging on your own individual thumbprints all the way through. Okay. Then we're going to get to, and then we have a table of the means and standard deviations. Again, no messing back and forth with that, silly SPSS. It has it here for you in 3 seconds. Okay, then it gets into the chi-square, okay, where we highlight, here's what we're looking for. We're looking at a relationship between these two variables. It reports in APA format what the results of that chi-square were. The chi-square symbol, the 2 degrees of freedom, the actual chi-square value, as well as the probability. And it's interpreting it for you, suggesting there was a relationship because that P is less than 0.05. Okay. Then it interprets, then it drills down into it. Okay, it's significant, that relationship. All right, well, how is it significant? That paragraph, there were less participants in high engagement in Group A group than expected. So what it's doing, okay, is literally showing this is the observed, 13, that's the expected for that cell. It's now dynamically interpreting the difference between the observed and the expected frequency, and it's putting it in plain English for you. Okay. Then we have the Pearson correlation. Again, tells you what you've done, what the analysis is, whether it was significant or not, and APA table. No messing around. This is also an assumption of the analyses that you show scatter plots around that linearity, homoscedasticity business that we showed earlier. Okay? Then it gets to the t-test. What the test was, it automatically puts in the assumptions of normality and equality of variance. Automatically puts it in, automatically interprets it. Amazing. Then it reports the results of that t-test, then gives you an APA table, okay? That is, here's the t-value, the significance level, 0.003, the effect size, a la Cohen, and then the means and standard deviations. Additionally, we also have an editable figure, okay? So, all right, multiple regression, the analyses, the assumptions, and the interpretation. A beautiful APA table showing it. Plots showing the assumptions, okay? All right. Mediation gives you the conditions for mediation, okay? Reports the F values of those ANOVAs. Then reports the table, the mediation table. All three regressions conducted, and it's interpreting it, okay? Then it has references of who we reference, okay? I also want to add that we're adding a glossary. We're adding an academy of different videos that you can walk through with this. Okay? This is the time. All right. Everybody got that? Very helpful tool. I have questions. Should I answer the questions? Okay. All right. I'm going to keep going, and then I'll answer questions after this. Again, the most learner-friendly, user-friendly interpreter of results on the planet. Absolutely. And it's only getting better day by day. Okay, I know I'm running out of time. So now I am all yours for questions, and I know we have several questions here. So let me just say, okay, so let me just make a few things before we get there. So to purchase the software, you can purchase it online, okay? Or you can email Melissa at statisticsolutions.com. Maybe we could send that out to him. Melissa, M-E-L-I-S-S-A, at statisticsolutions.com, okay? Or you can just order it on the website, currently $299. I will not guarantee that price a month down the road. Okay, and the other things I want to mention, I'm just going to jump to, we're doing a workshop in Atlanta this August the 30th, okay? This August, it's $299 is the early bird special, okay? That is if you sign up before June the 30th, okay, or July the 1st, you can get it for $299. The workshop's going to be terrific. How to complete your dissertation within 1 year. Who wants to complete your dissertation within 1 year? All of us do. So even if you're in the proposal phase, or even if you're in the results phase, you'll get enough out of the workshop to be moving through it. So seats are limited, $299. You know, pretty cheap. $399 after that. Okay. So let me just answer some of these questions here. Okay. What if you have more than 10 variables? Give us a call, and we'll run that for you. Okay? I mean, we sell consulting services, for gosh sake. So, yeah, you know. And what are you doing with more than 10 variables anyway, by the way? Okay? What are you doing? You want to graduate in 2017? You're going to interpret all of those? Okay, fine. All right. Can your website run three-way ANOVAs? Not yet. Forthcoming. Duly noted. Multiple regression. Do the IVs and the DVs have to be continuous, Robert? No, they don't. Dependent upon the kind of regression, we said there was 4 of them, right? So if your dependent variable was dichotomous, where you're running logistic regression, so different regressions can look at different types of DVs. The IVs can be anything, categorical, continuous, or ordinal, okay? So there's some dummy coding that needs to be done, is what they call it. Yes, so you can have different levels of measurement on both sides of that IV-DV equation. So I think I just answered Robert's question. Will the template identify the topic? I'm not quite sure what that question means. Okay. Does the software include Bonferroni? Yeah, it does. Thank you for the question. So what that is when you run lots of correlations, you need to correct the probability. So yes, we automatically include Bonferroni's correction in there. Good question, and thank you. Which also reminds me that there's lots of other bells and whistles in there that we didn't really show in this brief few-minute video. So, you know, for example, like automatically dummy coding those independent variables in the regression. Okay. Okay. So what else? Okay. Okay. More than one DV. Doing simple correlations. Likert scales have 0 some options. Okay. If you're centering, yeah, I mean, a lot of these things will be on an FAQ sheet. Okay, I mean, some people are asking higher level questions than really our audience is ready for. So I think we're, we're about there, okay? So maybe just one more question. Is the workshop for only one day? Yep, it's one day. It's in Atlanta, at the Atlanta airport. I think the room, at the Marriott. I think the rooms are relatively cheap. It's under $150 or something. But you can just stay right at the airport, have a good, solid workshop day. You'll get more out of it than those darn retreats too, because I'm going to be getting into it. Anyway, I hope the idea is to give you a preview of quantitative analyses, okay? This was just the beginning, okay? I should say, we assist students with results chapters, either hourly or the whole shebang by really working it through. I think people really ship out, stats and APA editing, both of which we do, okay? APA editing too. Tell your friends about us. Go to your social media, share us with your friends and colleagues, and feel free to give us a call. And it takes 2 seconds to send over an inquiry, okay? So go to the website, fill out an inquiry. It's free. You get a free 30-minute consult with me. We've been talking to lots of people for an hour. 30 minutes, totally free. And then we'll share, how we can assist you. Our goal is to move you forward. Move you forward in a process without beating your head against the wall. We want this process to be smooth for you, okay? That's the whole name of the game. So the software helps you smooth the process through. The consulting helps you smooth the process. We have great experienced staff. We're professional. We're A+ rated with the BBB. We were 100% successful, and I know we could be successful with you. I really want to say thank you. I appreciate everyone's attention, and we look forward to seeing you in Atlanta at the end of August. Terrific. Thanks so much. Love you all. Have a great night. Okay, bye now.